Hey everyone, welcome back. The glitchy behavior was super simple to explain. The problem is setting up our controller. I forgot to actually move up the character controller, so it was like trying to walk through the ground, and it just didn't like that very much. If we add Y of 1 to our center of our character controller, and then apply this to the prefab, we're going to have better luck with this. So let's take a look. There we go. So now we've actually got this really nice behavior here. Oh, got stuck a little bit, and I think it's lagging because of my debug log. Sometimes just doing a log every frame like that can really lag my computer. There we go. So we've got some path finding in the sense that if you click here, it's going to try and go around this obstacle. Now it's getting stuck, so that's something we can tune, but at the least it sort of understands the idea of obstacle. And we have this kind of not so great like jerky behavior, and the reason that that's happening is that the A* path returns to us is a series of grid. Let's take a look at our map. What A* path returns to us is a series of points along the grid, and like if you're going at an angle, you can only kind of do a zigzag, so it'll always be really glitchy. But what you can do is add a funnel modifier. So a funnel modifier, it applies to the seeker, and when the seeker gets a result path back, it will automatically modify it and smooth it out for you. And the funnel algorithm is something you can look up on Wikipedia, but it's not important for this tutorial. We just know that we want to add it to our game object. So we're gonna have to go back to the start scene. I don't know why there's two. Oh, I didn't delete it, and that gives us much smoother movement. I think that's a lot better. And one more thing, this just totally crowds out your debug log. So what you need to do to get rid of that is A* path script settings debug path log only errors, and that way you'll have your debug log to yourself. So we get rid of this copy of player entity, and there we go. We have, you know, our click move Diablo style controller. It's using A* path, and it's using Bolt to do the simulate and the execute loops, and yeah, I think it just, you know, it looks really nice the way it is. I think there's something going on with the width, like it's trying to find a path as if this capsule was a smaller width, so it thinks it can go around in a tighter shape than it really can. But for the purpose of this tutorial, we're just gonna move right on to setting up like a client server, multiple client game. So for that, we're gonna do it a bit hack and slash. It's possible, like if you were building out a bigger, you know, a bigger game, you might have two complete contexts. So we could start off with a rogue client context, and it would do all its bindings and whatnot, and then we might have a rogue server context, which might do different stuff. But all we want to do is just change one. We don't want to change our bindings, so we just want to change one thing that we do, which is basically how we start it, what command we run to start it. So let's start a start client command command. So this will actually be renamed to start server command. and we'll write a different start client command. So we're using strange command namespace. We're going to inject the public iGame service, and we're going to inject the context dispatcher. And we're going to override the execute method. Oy vey. Sometimes I don't like the stuff they do for you automatically in modern IDEs. That's often more wrong than right. But moving on. We're starting the client, and then we're going to add a listener for the service event connect response, because we're going to actually ask our game service to connect. Now we're going to click, we're going to call retain, and then we're going to say service connect to local host, and we're going to go on port 6900. And then we have a callback connect response. We'll say debug log connected to game server, and we'll say event bus remove listener service event start server response. Oops, sorry, connect response on connect response. It's getting a bit hard to see. We'll get rid of that, and then we'll release. So what we need to do is actually find a way to remap this, and we're going to do it in a sort of a hacky but more simple way by doing an editor setting. Bool is server, and we'll say it will start out as true. So our context view, if this even compiles. Public, whoops. We'll have an editor setting for whether it's the server or not. So it's the server. And then we'll pass it in as a third parameter to our rogue context. And we'll map this value conditionally. Now hopefully you can see, oops. So we'll need to say in the constructor, wow, this is server equals is server. Hopefully you guys can all see why this is super hacky, and it's not recommended that you do this in a more serious app, but right now, like, I don't think that we should bother copy pasting all this, but I also don't think that, you know, you want to do too much outside of the context. I mean, the context is supposed to be the root of all your apps, so to have something above that is kind of wrong. If you wanted to do a lot of configuration, what you should be doing is creating a iconfig of whatever you're configuring, and you know, you can have a JSON asset somewhere in resources, and you load it, and you turn it into a config class, and you bind it on a value, and that way you can access it in the rest of your app. Okay, so this should do us a solid, and start our client, if we say start client. But it shouldn't get any further than that because so we haven't implemented anything for this in our Bolt game service. Right, we didn't implement this method yet. So we'll say debug log starting client, and then we'll say Bolt launcher start client. Let me just take a look what we need to do here. We say that we're happy with UDP endpoint any. So the address of this client is whatever its local machine is, and then we'll say var server endpoint equals new UDP endpoint host. Well, we actually want to check for localhost. There's a special term for localhost. So what we'll say is if host equals host to lower equals localhost, we'll say UDP endpoint server endpoint server endpoint equals new UDP endpoint UDP IPv4 address localhost, and then U short of the port. Otherwise, it's going to actually just be the raw address. So if you're a little further along and you're hosting your server, yes, this will be UDP IPv4 address parse of the host. I don't have this right. So we'll parse that address. So if you're a little further along and you're like hosting a game server or multiple game servers on some cloud, or you have it hosted yourself, then you tell your clients to connect to that known IP. But for this, the purposes of this, we're going to run everything on localhost, which will only do it across your own computer's network. And once we've gotten the server endpoint, we will say Bolt network connect to the server endpoint, and that'll try and connect us to the Bolt network. Probably unlikely that this will work right off the bat because we're not running a server. But for the next video, I'm going to do a demonstration, and I'm going to build out the clients and the servers. Okay, thank you, bye.